Good afternoon, my YouTube viewers. It is Crystal. I'm just here because I want to go over another code review on a community competition, and it's going to be ML Olympiad. Can you guess the beer style? And you can see this is it. You can see this is my Kaggle page, and you can see I'm on Kaggle. I will say that I had problems getting the code to work, and because the people who hosted the competition, they didn't put the right submission set up, so I couldn't get it to work because the right submission set wasn't up. So I had to email them about that. And then I used two models. One model was logistic regression, and then another model was XGBoost, and it kept coming up as 0. And I thought, well, what's going on here? So I had to email them about that, and then they had to do some tweaking to get the scoring to work. But as you can see, I'm one of one. So I'm the only one who has entered this competition. So at the moment I'm leading if I'm the only one who's entered the competition. So that's good. Who knows, I might win. Because if I win, yeah, that'll be fantastic news if I win. So it says there's one team, and that's me. I'm a team. And we're going to go over to submissions. And we're going to check Beer Quality version 1. This is the code where I did use XGBoost. I used logistic regression, and I didn't even try that one. And then I used XGBoost. So this is the code. So you got 1 month to go. So if you want to outperform me, well, you got my code, and you can see what you can do to improve the score. A month to go, but at the moment, I'm one of one. So whenever I use XGBoost, I had a 90.5% accuracy, so that was good. So what we're going to do is we're going to go over the problem statement of this beer quality competition question. This is a machine learning competition focused on classifying beer into 17 distinct styles based on key descriptors. Participants will be provided with a dataset containing information such as IBU, international bitterness units, ABV, alcohol by volume, as well as professional ratings and descriptions. The goal is to develop a model that can accurately categorize beer into one of the 17 styles based on the provided descriptors. The competition is open to all machine learning enthusiasts and offers a unique opportunity to put your skills to the test and showcase your ability to tackle a complex classification problem. So that's your problem statement. So what we want to do is we've created the Jupyter notebook, and which is a free online Jupyter notebook hosted by Kaggle. And the first thing that we want to do is we want to import our libraries. So we're going to import NumPy as NP, which carries out numerical computations. And then we're going to import Pandas as PD, which carries out data processing, and it creates data frames and series. We're going to import OS, which goes into the operating system. We're going to import sklearn, which is for machine learning operations. We're going to import matplotlib.pyplot as PLT, which is to visualize the data, and we're going to import Seaborn as SNS, which also visualizes the data, but it performs statistics as well. So after we have imported our libraries, then what we're going to do is we're going to load our files using the OS library. And so when we load our files, we get sample submission, train, and test. So now what we're going to do is we're going to use Pandas to read the file. So train equals pd.read_csv, and then you get the link for train, and then we're going to do the same with test and sample submission, and we're going to name the files train, test, and submission. And what I want to do is I want to see all of the columns. So we're going to use Pandas to set it up so we can see all of the columns. So it's pd.set_option brackets display.max columns, comma, none. And then so what we'll do is we'll see all of the columns. And in train, we've got 518 rows by 27 columns, and you can see all of them. And then we do train info, so we find out which ones are objects, integers, and floats. And so there you go. You know which one's the integer, objects, and a float when we check info. So we want to see if we have any null characters, and you can see that in almost every column of data there's going to be some null values. So what we're going to do in the train data set is we're going to drop all of the null values. So when we drop all of the null values, we only have 191 rows. So our number of rows goes from 500 and something to 191. But the thing is that if there are different ways that you can deal with missing values, I choose to just drop them, but you can also convert them to mean, median, and mode if you like, and you can impute them and convert them, use KNN, but I just decided that I would drop them. So now what we want to do is we want to see how many unique values we have of each column. So let's just see where we go. For call in train, print brackets call dot train brackets call dot in unique. So you can see all the unique values you have for each column of data. We're going to do a value counts for the target, which is your train bracket style ID dot value counts, and what that does is that counts how many you have of each category. So it ranges from 18 to 4. So fortunately we don't have anything that's only 1, because if you had a value count of only 1, then you would need to drop those rows as well, because it adds little meaning to the prediction if you have only one value. So fortunately we didn't have that. We check our test set. The test is the same format except as the train set, except that it doesn't have the style ID. It has 58 columns really, and no style ID. We check for null values. You see we've got null values in the test set that are going to have to be dealt with. So we also check the unique values. So you see we've got a lot of unique values in the test set as well. And this is the submission. This is the submission file that appeared that I was supposed to do, and whenever I did it I thought to myself, oh well, they only want you to do 4. And what I had done was I was trying to select the ID number that corresponded with the ID in the test set, but I found out after a couple of hours of working that the ID numbers in the submission were not the same as the ID numbers in the test set, and you had 58 rows in the test set and only 4 rows in the submission. But nevertheless, I was going to try to enter this competition because I thought that, this was something that they wanted. And then I worked on it for several hours. And finally, I had to send a message. If you look in the discussion board, I sent a message saying that there were only 4 rows of data in the submission and none of the rows of data related to the test. So they went through and changed the submission, but it didn't matter because and then after that, after that, they changed the submission. Whenever I ran it up, I only got a 0. And I thought to myself, a 0? How is this? So I ran it up on logistic regression, and I got one value. I got a 0. And then I used XGBoost. I ran it up on XGBoost, and I thought, well, surely I'll get an improvement on XGBoost. And I got a 0 on XGBoost, so I had to send a message saying, look, it always comes up with 0s. So do you have any suggestions? So they had to go through and they had to tweak the scoring as well. So I had to send them 2 emails or 2 messages to get it to work. So now what we're going to do is we're going to use Seaborn to analyze our target. So you've got sns.dispplot brackets train brackets style ID brackets comma KD equals true. So we get a displot, and you get the histogram, and then you also get the little curve to see what kind of a curve that it makes. That's your target. So now what we're going to do is we're going to take our target and we're going to define our target as being train brackets style ID, and then we're going to create another data frame called combi, and we're going to create that by dropping the target from train and appending test to it. So now we've got combi, and then what we're going to do is on combi, what we're going to do is we are going to drop all of the columns that are object columns, because they're not really they're not necessary in order to make a prediction, and in addition to not being necessary, they could actually introduce noise into the system. So we dropped all of the object columns. So you can see here combi equals combi.select d types brackets exclude equals brackets object brackets. So now you see that we've got a data frame of 249 rows by 21 columns, and you can see it's all numeric. But we don't really need the IED either, because every row of data has its own IED, and every row of data is indexed. So you're going to know what row of data that you're working on because it's indexed. And then, so it doesn't add anything to the prediction, so it's best to just drop that as well. Then we're going to check for null values. We see that we've got quite a few null values in combi. So what we're going to do is for call in combi brackets call dot fill in a brackets combi brackets call dot mean brackets comma in place equals true. And so what we're doing is we are replacing all the null values with the mean, and because all of the values are floats, so you can do that. You can see we don't have any more null values after we've done that. Then we check our heat map. Core equals combi.core, and then we create a heat map using Seaborn sns.heatmap brackets core. So you can see you've got the heat map, and you can see that none of the columns are highly correlated, which is good. And since none of the columns are highly correlated, that means I don't have to do anything to remove highly correlated columns. So this is core, so you can see the correlation that each column has to its neighbor. Now what we're going to do is we're going to normalize the data, and when you normalize the data, what happens is you convert all of the cell values to a value between 0 and 1. And the reason why you do that is because it's easier for the model to make predictions if the data is close together, close by. So here you can see all of the cell values are a value between 0 and 1 after I've normalized the data. Now what we're going to do is we're going to define our x and our y value variables. Y is your target, and then your x and x test are combi. X is combi, row 0 to the length of train, and x test is combi, the length of train to the end. And now what we're going to do is we're going to insert code to take the x variable and convert it into a training and validation data set. So x brackets target equals target, train equals x dot sample, and then I said frac equals 0.8, random state equals 42, val equals x dot drop, train dot index. So you create your validation set by just dropping all of the sampled, all of the rows that had been previously sampled to make train. And then X train is all of the rows except for the last one, and Y train is, all of the columns except for the last one, and Y train is the last column. X val is all of the columns except for the last one, and Y val is the last one. And then we check our shape, so you can see the shape. We started out with, I think, like 27 columns, and now we've only got 20 columns of data. So we removed a lot of unnecessary columns. And when you remove those unnecessary columns, then you improve the possibility of making a good prediction. So now what we do is we select model. So we're going to select XGB classifier. And we got 100% accuracy when we trained and fitted the data into the model. And now we're going to predict on our validation set, and we got 84% accuracy when we predicted on it. So I made a confusion matrix, and so here is your confusion matrix. So what we're going to do is we're going to compare the actual values, which is y val, to the predicted values, which is y pred. So you can compare the actual values to the predicted values. Now we're going to predict on the test set. So prediction equals model.predict x test. Prediction equals PD data frame prediction. And I had to do all of this stuff because I was messing around trying to get it to work, not knowing that they had made a mistake when they hosted the competition. So prediction.rename columns, prediction.column 0 is style ID, in place equals true, prediction ID equals test ID, and then prediction. So now under prediction, you've got style ID and ID. So now what we do is we prepare the submission. So again, I was doing a lot of work to try to get this to work. So submit equals pd.dataframe. You're making a blank data frame. Submit ID equals prediction ID. Submit style ID equals prediction style ID. Submit to CSV bracket submission index equals false. Submission equals PD reads CSV submission, and this is your submission. And so this is what I submitted to Kaggle. And I saved it. And then whenever I saved it, I had my data. And then whenever I had my data, I submitted it. And then I submitted it again because they sent me an email and they said, oh, well, we had to change some information. And if you submit it again, it'll give you a good score. So I submitted it again, and it gave me a good score. It gave me a score of over 90%, 90.555%. So I'm happy with that. And so that's it. That's the code review. So we've gone through the complete code review. You can see where we go. We can come back here to predictions. And oh, someone else has, now I'm 2 of 2. Someone else has done it. Someone else has entered the competitions. It says one team, a month to go, and then it says leaderboard. And so someone called Old Jerry is now a 96%, so I don't know if he used my code to get where he's at, but he's 96%. So now I'm 2 of 2. At the beginning of this code review, I was 1 of 1, but Old Jerry went through, and now he's 96%, so he's 6 points higher than me. And so there you go. So someone has done better than me. I don't know if he did it because he looked at my code and modeled his code after mine, or if he just had his own ideas. But I'll never know because I'm not going to email old Jerry and find out. But that's it. I'm going to have to go ahead and conclude the code review because we reviewed the code, we reviewed the leaderboard, we reviewed the data, we reviewed everything. The only thing I can do is talk to you about the discussion. And so you can see we had two discussion points, and both of these discussion points were raised by myself. And so because I made the discussion points, I got it so that the competition was usable. So I would like to thank you for watching my video. I would like to thank all of my subscribers for supporting my channel. And I'm going to go ahead and conclude this video. I look forward to making more videos for you in the future.